Hi, everybody. This is John Bowero. I'm a channel solutions engineer for HashiCorp, meaning I get to enable our partners. I live in London and I cover Europe, Middle East, and Africa. Now, I'm here today to talk to you about HashiFUSE. So this is a project that I've had going for almost 3 years now in various stages. And what I do is create some Fuse file systems that map the HashiCorp APIs into familiar environment, a familiar file system structure, which you can easily use with your CLI, any APIs you have, any language you have that can read and write files. So why do I do it? It simplifies the APIs quite a bit. It allows things like auto-completion, some real nice features that we'll see and towards the demos at the end. Now, if you're not familiar with Fuse, it's a file system in user space. So really, it's just a simple little application that interacts with a kernel module, the Fuse kernel module, which will actually do switches between user space and kernel space to present an application, inputs, outputs, and a couple of mappings that I'll talk about later into what the kernel views as a traditional file system. So it's a simple, tiny binary. I've done Vault, I've done Console, I've done Nomad, Terraform Enterprise, and Terraform Cloud, and also a generic OpenAPI one, which is really interesting because as more of our products adopt OpenAPI version 3, we have a more uniform way and a single client which can actually be used to access any of our projects potentially. And I'll talk about the future plans as well. So why does it matter? Again, if you're old school Unix, Linux user, one of the beautiful things about the standards presented by POSIX, everything has been a file. That's not actually part of the POSIX standard, but common way to use just about anything in a Linux environment today is via file. Your sound devices are files, random numbers are files, right? Everything in your system tends to be represented in some way or another as a file. Now, the great way we do this is we do the same thing with Vault Secrets or Terraform workspaces, right? So you can browse your workspaces, you can browse your secrets just like you would a normal file system. Now, in order to implement one of these, Fuse has a couple of prerequisites that you need to implement to make a file system, right? The most important one at the top is get attribute, right? So if you're given a path, what is this? Is this a file? Is this a directory? What permissions do I have, ownership, etc.? Is it a socket? Is it a symlink? So you have to fill a stat buffer based on a path. Now, the APIs don't necessarily have those defined, right? OpenAPI version 3, the specs that we have for Vault are really good. They tell you exactly what paths you have available, what those paths represent, what operations you have, a post, a get, a patch, whatever you have. Now, for the rest of them, and for the early Vault client that I made, I had to approximate that, right? I had to use a bunch of regular expressions. If the path looks like this, it's a directory. If the path looks like that, it's a file. Now, it's actually not as complicated as it sounds. It's only about 800 lines, I think, tops of C++. So everything is pretty straightforward, pretty simple. And it's not feature complete, right? So there's not exactly every feature built in, but a pretty good basis for most of the Vault secret engines and like Terraform Cloud API, etc. All right, so when you implement a full CRUD-L, I call it CRUD-L, create, read, update, delete, and also list, or in this case, read directory, we get a fully browsable file system. So what this looks like, and here's an example of me running the Fuse client for Terraform Cloud. So I use libjson C++, libcurl. You do need to use direct.io because if you don't use direct.io, the kernel will attempt to cache things, and a REST API will not have the same response most times if you're going to repeatedly fetch it, right? So we will recommend, you will have to use Fuse in direct.io if you're going to use any of these clients. The Vault one, the Terraform one will use the same environment variables as you're used to, right? So Terraform token, TFE token, Vault token, Vault address, all of those translate directly from your existing CLI into the Fuse file systems. And in the case of the OpenAPI one, further on, I actually have implemented fetching your client's environment variables. So you can do things like your headers. Obviously, it's more complicated when you have to do things like a header for namespace, header for payload, whatever kind of flags you're having. That can be pulled from your environment variables now, which is really helpful. Feel free to take a look at the code. It's only something like 3 pages if you print it out. I'm not a full-time coder anymore, and I would love to port these to Go, but all of my stars and stripes are in C++ land still, because I still like to code in C++ occasionally. Okay, new feature that I recently added since the last Hashi Talks when I did this, we, as users, it's never been easy to do a complex transaction with a file system, right? You do a read, you do a write, but you can't do a write and get a read out of it. So if you've ever used Bash's dev TCP device, this is a really interesting concept. So it was a virtual path within Bash. You can echo something to it on a port and get a response out via your third file descriptor. So if you're familiar with Linux or normal Unix file descriptors, every process has FD0, which is standard in, FD1, which is standard out, FD2, which is standard error, FD3, which is actually a bonus one, right? Not many people use FD3. So now I have implemented to the point where if you do a write or a post or a put or any REST call that returns output, but required a write, you weren't able to see that previously, right? The FUSE process is not attached to your client process wherever you're reading it from. But what I do now is an experiment is I take your FUSE context, I get your process ID, and I dump any output to that standard out, right? So your proc/u, whatever your client is, /fd/1 gets any, I attempt to write any output to it. So it's really helpful because you can actually use this for complex transactions within Vault. You need to copy a base64 payload into encrypt or decrypt, or assign in this case, where I do this example in a GIF. So you echo the plain text with the base64 to a file, whatever you take to get that into a file. And then you can browse the transit secret engine or any path really within Vault, copy that to Vault, and note that copy, the CP command normally wouldn't have standard out, right? Unless there's a problem, it would go to standard error. But here we see we copy a payload to a file, and then we get standard out, we get JSON dump, right? So you can actually pipe that into JQ like I did right here. Now, if you're writing your own process, you're doing a read or write transaction, you can do the same thing, right? You can actually switch it to use FD3 if you don't want to interfere with your standard out. You can choose which file descriptor you want to put that out to if you do a build. So I'd be curious if anybody finds that useful, or I've certainly not tried it on every endpoint. You can do things like generate random numbers. You have to tell it, Vault, how many bytes of random numbers you would want, how much entropy, whatever you want to specify as part of the API. Now you can get that out with a simple file operation. So anybody, feel free to experiment with that. Let me know in GitHub if you have feedback on that. Okay. If you are using this for a Kubernetes sidecar, the good news is it's a great option for a sidecar. It's tiny, something like 28K dynamically linked, and maybe about 40K, I think, statically linked with libcurl and libc++. libjson C++. So it's a great option to say, use this, you effectively mount it as a volume, right? You can use FUSE file systems as volumes that would be bound to your pod and your Kubernetes deployment. Use your service account to authenticate to Vault, for example. That service account exposes you to policies, and you get access to whatever secrets that policy gives you, right? So here in this case, we say within the pod, if I tree my mount, VaultFS, or wherever I'm going to mount that volume, I can browse my PKI certificates. I can even request my own, right? So each pod will get its own certificate, and I don't have to worry about the Vault binary being injected as a sidecar, right? Because that is kind of a heavyweight sidecar at this point. So really lightweight. It's, again, a simple process just to have a separate file system mounted as a volume, and you treat it as your normal Vault without having to worry about any of the API mappings. Okay, future enhancements, again, I would love to deploy it to Go. Again, I'm not a full-time coder anymore, so I've started to do a little bit. So one of the engineers at HashiCorp actually did a really great job porting an early version of the Vault client to Go. And it actually works pretty well. If there's more interest in that, I'm happy to work with the community and devote some more time to it. In the meantime, I just experiment a little bit more with the OpenAPI support. So that's my target now. I'm developing mostly on the OpenAPI one because in our near future, we will have more products that will support OpenAPI specs. Nomad is being discussed right now. I'm hoping Consul will have it eventually. And obviously Terraform Enterprise has its own API. I don't know that that will support OpenAPI version 3 specs, but schemas, I should say, but fingers crossed. So as we do that, as we get more products implementing OpenAPI standards, then we essentially could have one agent that is used to browse any of our products, right? Don't have to worry about complex and bulky CLIs. All you have to do is have this universal client, okay? Number 3, indirect IO cache. I would love to support that. It's not easy. It's not easy in concept because you can obviously take advantage of the kernel cache, which would cache your secrets, cache your whatever you're fetching out of Terraform Enterprise, etc. The problem is you don't know necessarily how long to cache that, right? Also, with direct IO, you must read or write the entire payload at once. A file system normally will divide up into 4 kilobyte chunks, or I should say whatever the default block size for the operation is. So once you use direct IO with big writes as a FUSE file system mount, you get the ability to write larger payloads. Otherwise, if you exceed that, you have to divide that up into smaller blocks, and that tends to break this functionality because you fetch the same API request twice. So I think that's 130 kilobytes is the maximum payload that you can transact right now, depending on your FUSE implementation. Okay, also Git support, and this is an interesting idea, not necessarily something that I need to implement, but the fact that you could mount a Git repository, view all versions, view all branches, etc., locally, and then not have to worry about the Git CLI. That would be interesting as well, wouldn't it? Possibly, we'll see in the future. And 5, again, I talked about the HashiCorp OpenAPI support. It would be great. I would love to see it more developed. I have the draft actually that I've put together as part of the last talk, and I have improved upon it a bit actually with the standard out, right? So I talked about when you copy or write something to a post endpoint, you normally wouldn't get anything out because that's not how a file system transacts. But now you can do that. You can copy whatever your payload is to a post endpoint, to a put, and have that standard out dumped to your terminal, which is really useful. And whatever process you use, it doesn't matter. It all comes to your standard out. So that is growing in support. I think the OpenAPI client, again, will be big. I do think that there's a problem with the OpenAPI version 3 standard that I wish I could have everything laid out as a tree. The OpenAPI version 3 spec, if you've ever looked at one from Vault, isn't really a tree, it's a list of endpoints, right? So that is difficult when you have to do a get attribute on each directory along a path. You have to say, okay, path root is a directory, transit is a directory, and then, but if there's a large path that has something like 5 levels deep, you have to actually parse each one and make sure that you're a directory along each step of the way. So we'll see if I could actually have the OpenAPI 3 spec, or maybe OpenAPI version 4 spec be modified. That would be on my wish list for sure. In the meantime, it's not impossible. It's not difficult. I will implement that at some point as well. But you can see for yourself. You can browse your Vault API. The OpenAPI version 3 support in Vault is actually really good. It's fantastic. So if you're a user of that, give it a try. Again, it's open source in enterprise since I think version 1.1 or 1.2. So really helpful feature. Look for it soon in Nomad. I'm thinking that's going to make a big deal to Nomad. And yeah, if there's any other product that you want to push for OpenAPI support, or engineering teams to support the FUSE clients as well, just let us know on the community on GitHub or discuss. So anyway, I hope that's been informative to you. I would propose a conclusion and a challenge. All of the repos you see are available. HashiFUSE contains all of the repo clients that I have. I build, all of the HashiFUSE clients. They're a single file, most of them, a single C++ file. And I do build automation on the Fedora Copper system. So if you want a repo where you can download these and track with the updates, feel free to jump on board. Otherwise, you can build from source anytime. It's just a simple make file. As long as you have libfuse, it works. So repo for all of the clients is there. Repo for this presentation that I use is there as well. Pull requests and ports are welcome, and I love feedback. So anybody has any feedback, I'm happy to hear it. Okay. In the meantime, thank you. Enjoy the rest of your Hashi talks. This is John Boero again, and have a great day. Cheers. Bye.